Object-oriented programming interview questions in the context of automation testing with real-life examples. Object-oriented programming, or OOP, is a programming paradigm that uses objects to structure and organize code. It's a key concept in automation testing. The core principles of OOP are encapsulation, inheritance, and polymorphism. These principles model real-world entities and their interactions. In automation testing, a test case can be considered an object. A class is created for each type of test case. These classes encapsulate the test data, methods, and assertions. For instance, a login page test class can encapsulate test data like usernames and passwords. It also includes methods to simulate login actions and validate login success. Classes and objects are key concepts in OOP. A class is a blueprint for creating objects. It defines the structure, attributes, and behaviors that objects of that class will have. An object is an instance of a class. In automation testing, a class can be a template for a test scenario, like a login page. An object would be a specific test case, like a test for a successful login. The class defines the common attributes and methods shared by all login test cases. Let's look at an example of a login page test class and a test case object. The class has attributes like username field, password field, and login button. It also has methods like enter username, enter password, click login button, and verify login success. The login page test, our test case 1 object, is an instance of the login page test class. It refers to specific elements on the web page for this test case. It also has test data specific to this test case, like username and password. In this example, the login page test class serves as a blueprint for test cases related to a login page. The login page test case 1 object is a specific instance of this class, tailored to a particular test scenario. This demonstrates how OOP principles are applied in automation testing to create a structured and reusable framework for testing different scenarios. Encapsulation in automation testing. Protecting sensitive data. Encapsulation is a concept that bundles data and methods into a single unit, a class. It hides internal details and exposes a well-defined interface. In automation testing, encapsulation is applied by creating classes for web pages. For instance, a login page class can contain private attributes for username and password fields. It also has public methods for entering credentials and clicking the login button. This way, the implementation details are hidden from test cases. Let's look at an example of how encapsulation protects sensitive data in automation testing. Consider a class login page test. It has 2 private attributes, username field and password field. These represent the username and password input fields. The class also has 2 private methods, enter username and enter password. These methods allow entering a username and password into the respective fields. By making them private, external code cannot directly call these methods, protecting the details of how the username and password are entered. Encapsulation in the login page test class provides several benefits for data protection. 1. Data. Hiding. Encapsulation hides the internal details of the class from external code. Sensitive data like username field and password field are not directly accessible from outside the class, making it harder for unauthorized access. 2. Controlled access. The private methods can only be called from within the class itself. This controlled access ensures that sensitive data is manipulated only through the designated methods, and unauthorized access is prevented. 3. Reduced risk. By encapsulating sensitive data, you reduce the risk of data exposure or unintentional modification by external code. This is crucial when working with sensitive information in testing scenarios, where data security is paramount. 4. Improved code. Maintainability. Encapsulation allows you to change the internal implementation of the class without affecting the external code that uses the class. This separation of concerns simplifies maintenance and updates. In summary, encapsulation in the login page test class safeguards sensitive data by restricting direct access and modification from external code. It enhances data security and ensures that sensitive information is handled within a controlled and protected environment, which is essential in automation testing, where confidential data like login credentials is used. Understanding inheritance in automation testing. Inheritance is a key mechanism in automation testing. It allows a new class to inherit properties and behaviors from an existing class. This promotes code reusability and creates a hierarchy of classes. Consider a base class named baseTest. It contains common setup and teardown methods for browser automation. New test classes like login page test and registration page test can inherit these methods. This way, the browser setup and teardown logic is reused across multiple test cases. Let's illustrate how inheritance works with a base class and a derived class. The baseTest class has an attribute driver, representing the WebDriver instance used for browser automation. It has methods like setupDriver, openURL, and closeDriver. These methods set up the WebDriver, navigate to a URL, and close the WebDriver respectively. Login page test inherits from baseTest. It has web elements like username field, password field, and login button. It also has methods to enter a username, enter a password, click the login button, and verify login success. Login page test inherits from baseTest. Here's how inheritance benefits automation testing. 1. Code reusability. The baseTest class has common attributes and methods. Login page test inherits these, allowing it to reuse and build upon this functionality. 2. Specialization. baseTest provides generic browser automation functionality. Login page test specializes in testing login pages. It has its own attributes and methods for this specific test scenario. 3. Consistency. Inheritance promotes consistency across test cases. All test cases derived from baseTest have a consistent way of setting up and tearing down the WebDriver. 4. Efficiency. When updates are made to the base class, all derived classes benefit from these changes without requiring individual updates. Inheritance in automation testing allows for a structured and efficient test automation framework. The base class encapsulates common setup and teardown logic, while derived classes focus on specific testing scenarios. This enhances code reusability, maintainability, and consistency, making it a valuable practice in automation testing. Understanding polymorphism in automation testing. Polymorphism is a concept that allows objects of different classes to be treated as objects of a common base class. It's a key player in automation testing, enabling flexibility and extensibility. In automation testing, you might have a base class for interacting with web elements. Then, you create new classes for specific element types like buttons, input fields, and checkboxes. All these classes can implement a common method, like click, in a way that's relevant to their specific element type. Let's consider a base class and two derived classes to illustrate how polymorphism works. Our base class is WebElementInteractions. It has methods like click, setValue, and getAttribute. Derived class 1 is ButtonInteractions. It inherits from WebElementInteractions and overrides the click method. It also has a method to check if the button element is enabled. Discrete. Derived class 2 is TextFieldInteractions. It also inherits from WebElementInteractions and overrides the setValue method. It has methods to clear the text and retrieve the text from a text field element. In this example, polymorphism allows objects of different classes to respond to the same method calls in a way that is appropriate for their specific class. Here's how polymorphism benefits automation testing. 1. Method. Overriding. Both button interactions and text field interactions classes override methods from the base class. They provide specialized implementations of these methods to cater to the unique behavior of button elements and text fields. 2. Consistent interface. Despite the method overriding, automation test scripts that use web element interactions as a reference can interact with both button and text field elements in a consistent manner. 3. Flexibility. Automation testers can use the same interface for interacting with various web elements. This simplifies test script development and maintenance. 4. Code reusability. Testers can reuse common interactions across multiple element types, promoting efficient test script development. Polymorphism, by allowing different classes to respond to the same method calls, enables a consistent and flexible approach to interacting with web elements in automation testing. It simplifies script development, promotes code reusability, and makes it easier to work with a variety of element types while maintaining a clean and maintainable codebase. Understanding abstraction in automation testing. Abstraction is a process that simplifies complex systems. It breaks them into smaller, more manageable parts, hiding unnecessary details and exposing only essential features. In automation testing, abstraction is applied by creating a high-level test script. This script uses abstract methods or functions to represent test steps. These methods can be implemented in different test classes, allowing the same test script to run on different platforms or browsers with minimal changes. Let's consider an abstract class, web page. It has attributes like the title of the web page. It also has abstract methods like load, getTitle, and clickElement. These methods load a web page, retrieve its title, and click on a web element. Login page is a concrete implementation of web page. It overrides the abstract methods to load a specific URL associated with the login page, retrieve the login page's title, and perform a click action on a web element specific to the login page. Homepage is another concrete implementation of web page. It overrides the abstract methods to load a different URL associated with the home page, retrieve the home page's title, and perform a click action on a web element specific to the home page. Abstraction benefits automation testing in several ways. It ensures a consistent interface for interacting with web pages. It provides a high-level design for web pages, abstracting common characteristics and behaviors. It offers flexibility, allowing testers to work with different web pages using the same high-level interface. And it promotes code reusability across different pages. Abstraction, by defining a common interface and leaving the implementation details to concrete classes, simplifies automation testing. It allows testers to work at a higher level of design and provides a consistent and flexible approach to interacting with different web pages. What is a constructor, and how does it differ from a regular method? A constructor is a special method in a class. It's used to initialize objects when they're created. Typically, it's called automatically when an object is instantiated. Constructors share the same name as the class and don't have a return type. They're used to set initial values for object properties. Consider this example. We have a public class, login page test. It has a constructor that initializes the test case. It sets the initial values for the WebDriver and base URL. Now, let's talk about regular methods. These are different from constructors. They perform specific tasks and can return a value. They don't initialize objects. Take a look at this example. We have a public class, common utilities. It has a method called takeScreenshot. This method captures a screenshot. It's a regular method, not a constructor. What is the importance of the page object model, POM, in automation testing, and how does it relate to OOP principles? The page object model, POM, is crucial in automation testing as it enhances code maintainability and reusability. It relates to object-oriented programming, OOP principles, as follows. Encapsulation. POM encapsulates the structure and interactions of web pages into classes. Each class represents a page or component, encapsulating elements and their actions. Abstraction. POM abstracts page-specific details and actions, providing a high-level interface to interact with web pages. Inheritance. POM can use inheritance to establish a hierarchy of page objects, with common behaviors in a base class and page-specific behaviors in derived classes. Explain the difference between static and instance variables and methods in automation testing. When would you use one over the other? Static variables and methods. These belong to the class shared among all instances and are used for shared data or behaviors. Use them for utility functions, constants, or data that doesn't change across instances. Instance variables and methods. These are unique to each instance, holding instance-specific data or behaviors. Use them for properties and methods that depend on the specific state of an object. How can you implement method overloading and method overriding in test automation frameworks? And what benefits do they offer? Method overloading. Implementing method overloading means having multiple methods with the same name but different parameters. It offers flexibility, improving code readability and reusability in test automation. For example, you can create overloaded methods for the same action but with different types of input data.